I think everyone's here, so welcome everyone. Thanks for participating in this class. My name is Scott Williams. Some of you probably know me as the Certificate for Engineering for Energy Sustainability Administrator. I've probably met with a few of you here. You might have taken a seminar class that I also teach, or might be taking it this semester as well. So this class is kind of an experiment. This is the first time we're offering this class, and it's meant to bring together interdisciplinary teams to work on a project related to energy and sustainability. And so to help me out here, I've got a couple of co-instructors, John Murphy. Many of you in engineering probably know him from freshman engineering design class, and Gus Quaid, who will be our student assistant. So John, you want to say a few words about yourself?
Sure. So how many of you guys took 160 or something like that? So, okay, so you remember the horror story of 160. You remember my face at least. So my quick background is a long time ago, I got a math degree here. Went on, studied mechanical engineering in graduate school, got a master's. I went and worked in aerospace for 4 years, came back and worked in demand side management, and then eventually came back to UW and got a master's in nuclear engineering. So I teach nuclear engineering and mechanical engineering courses now. I did nuclear research for about 10 years. That may or may not be germane, probably not to what we're doing in this class, but if you have any questions as you go through and you want to learn more about mechanical engineering or cycles and things like that, well, a big part of this class is asking questions. And so don't be shy. Come up to us anytime you want. All right?
Yes.
Hi, I'm Gus Quaid. I'm a senior in biological systems engineering. If maybe some of you have seen me in 160, I was an essay in that class and then also a fabrication consultant. So I got into the labs and helped with the fabrication of the projects. I'm also a mechanical engineer intern at Gilson Inc., a liquid handling company in Middleton, and I'll be helping out in this class with homework and answering questions and fabrication and really anything that you guys need help with that they don't want to help you with.
Which will be most of it.
Most of it,
yeah. Yeah, so I'll give a little bit of my background. I studied journalism and history as an undergrad, worked for a couple years at NBC 15 here, came back for a master's in public affairs at the Wolf Hall School for Public Affairs. There's also a certificate at the graduate level called Energy Analysis and Policy, and that's where I really got interested in energy and sustainability issues. And so you can kind of tell already there's a little bit of a balance between the non-engineer who's more interested in energy policy and sustainability in the environment, and we have more of the engineering experts here. And that's going to happen too with this class. Is you'll all be working in interdisciplinary teams, and each of you has various strengths that we'll tap into to work on a design project for the course of the semester. And so we'll be providing details today just about kind of the structure of the course, what the expectations are. And then tomorrow we'll hit the ground running with kind of an intro to the design process. It might be a review for some of you, but it's always a good refresher. And we'll have other lectures about sustainability and energy systems throughout the semester. Should we go around and have everyone introduce themselves?
I think it's a great idea. Yeah, we could just start right here and maybe stand up. And part of this is it might seem a little hokey, but you guys are going to be working together all semester long. So don't be shy. You're going to have to get to know each other, and teams might mix and change. Probably not when you're working on the project, but early on we're going to be doing different these. So you really have to get to know each other. We push this concept that before you can even design your product, you got to design your team. So these soft skills are real important. So stand up and maybe give us tell us who you are.
Sure.
Maybe your degree and maybe what interests you in this class.
Okay, I'm James Averill. I'm a senior in civil and environmental. I've done most of my coursework focusing on structural engineering, but I got into this stuff. I took intro to electrical engineering and then renewable systems and biological systems department. My internship history has mostly been in construction management, but I did do last summer I worked with the DOT and their bridge rating unit, so know a little bit about bridge structures, but looking to learn more about the environmental side of the civil major. So
Great.
My name is John Loving. I'm a junior in electrical engineering. I don't know, I really got interested in sustainability and this side of things last summer when I went on a service trip to North Dakota, focused on like fracking and the effects on the communities in that area. And so I decided to pursue the sustainability energy sustainability certificate.
So my name is Christine. I'm a senior studying electrical engineering as well. I got interested in taking this class because I took last semester an alternative energy course that was just for like electronic systems. I thought that was really interesting, so I wanted to continue.
I'm Dakota. I'm a chemical engineer. I am interested in sustainability and recently switched to engineering because I wanted a stronger background in math. So I'm hoping to use this class to find ways to combine engineering and sustainability. So I'm very excited.
My name is Matt. I'm not an engineer, but I'm taking this primarily as my capstone for sustainability. So I'm interested in sustainability and entrepreneurship as well.
What are you studying?
Sorry?
What are you studying? What's your
I'm
major?
getting a certificate in sustainability and entrepreneurship at ComArts is my major.
Oh, okay.
Yeah, so.
I'm Alex. I'm a senior in electrical engineering, and I didn't really work on this stuff, so this was more of like exploring to see what it's like.
Okay.
My name is Jim. I actually started school at UW Stevens Point as a paper science student. And I interned at Green Bay Packaging and a couple other mills. At the time, there was a lot of like consolidation with the paper industry, so I kind of got scared off from that degree path. So I guess broadened the focus on doing environmental science now, but I still have like a lot of the core of engineering. So I thought this would be a good way to just wrap up like the policy and geography courses with the engineering courses that I'd already taken. So it just seemed like a perfect fit.
I'm Todd. I'm a junior economics major. I'm taking this course because I'm interested in finance or business side of renewable energy, and I just look for a more hands-on approach on different classes.
I'm Tom. I'm a senior in physics and Chinese, and I'm really interested in sustainable energy engineering. I'm actually doing this certificate.
My name's Paul. I'm econ and environmental studies major. I'm a senior, and I'm hoping to declare the certificate for energy sustainability for engineering. It's pretty soon. I got interested in sustainability when I had the great opportunity to be a research intern at Food Wisconsin this summer, which is a local environmental group, and they had me on a project modeling the impacts of rooftop solar in the Midwest on carbon emissions, and so I was really fascinated by the whole energy sustainability thing. So it's around me here.
I'm Danny. I'm a junior in chemical engineering. I just think energy and sustainability is really cool and also very important. So this class seems it should be fun.
I'm Brent. I'm a sophomore in chemical engineering, and I'm just interested in sustainability. That's a particular reason why it just interests me.
Hi everyone, I'm Jake. I'm in BSc and I'm in a certificate, and I really like design, so that's what I'm thinking about.
I'm Marianne. My major is environmental science, and I took this class after like renewable energies 360 something.
367.
Sure.
Okay.
Hi, I'm Bailey. I am a junior in environmental science.
As well, I started with civil, changed to environmental, and now I'm kind of getting back into the engineering a little bit with the certificate for energy sustainability. This is my capstone.
I'm Griffin. I'm double majoring in chemistry and chemical engineering. I'm also in the certificate program. Interested in this class because of the team aspect, and I think that energy and sustainability is the future.
Hey, my name is Han. I'm a senior studying biological systems engineering and certificate in physics and thermal energy system. I guess I'm very into renewable energy technology. Sure, so that's fine.
Hey, I'm Matthew. I'm a junior studying environmental science and philosophy. I'd like to declare the engineering certificate. I studied abroad in Iceland 2 years ago, and saw firsthand a lot of renewable energy systems implemented there. Thought it was really cool, and then took BSc 367. Thought this would be a good continuation of that too.
I'm Mitch. I'm a senior in electrical engineering, and I'm going for the certificate in energy sustainability. I studied abroad in China last summer, And I'm also getting a certificate in international engineering, so I was thinking of tying all that together because China's doing a lot of cool solar, wind, and hydropower stuff. So I'd like to get more into that.
And I'm Chris. I'm a senior in environmental science and studies, and then I'm going for a certificate also. I just wanted to take the class to get some hands-on experience before kind of going off in the real world.
So how many are taking this class? First for the energy sustainability certificate in engineering for the capstone. Okay, good majority. How many for the sustainability certificate? This one. Okay. And how many neither? Just interested in the class? Okay, it's a good mix. Whatever your motivation is, we're glad you're here. And we hope this will be a fun experience. Like I said, this is an experiment. This is a new course that we've developed, and we're melding different parts of campus together. And so we really want you to enjoy your time and working in teams and working on some projects that you feel passionate about. The next orders of business, office hours will all be by appointment. By the way, this is being recorded, so and all the lectures on Fridays will also be recorded, so that'll be available on the Canvas website. Basically, everything is going to be posted on the Canvas website. If you have any questions, the slides will be on the Canvas website. And if you want to schedule a meeting with any of us, you can either click on the links to those scheduling assistants or get in touch with Professor Murphy as well. With that, I think I'll turn it over to John to give a little bit more background on the course.
Thank you. Okay, so we're just going to go through some of an overview of the course today. This is again going to be very interactive, so feel free to chime in anytime you want with a comment. And even though these are discussions on Thursday tentatively, and then we have a 3-hour period on Friday, we'll take breaks. We'll usually start that with a lecture. Sometimes we're going to have lectures during discussion, and sometimes we'll have more discussion time during Friday. It's going to be a mix of things. You'll see on the Canvas webpage when we get to that you should probably that's the one assignment is to bookmark that today essentially. But you're going to see that we're going to have sort of a free format as we go through. So there's no textbook for the class. We want you to take thorough notes, but I would argue that the thorough notes that are going to be very important are when you're in a team and you're working in a group. So we'll show it to you right now. I'm probably got it at a later slide. We want you all to pick up this notebook. And Gus, you can get that on Amazon for $7.50. It's $15 down at the bookstore. But if you want to just order it on Amazon, I think you can get it for $7.50.
Yeah.
Is that
the links are up there?
Okay.
Each website there.
Oh, all right. So just go right to this website and you can find it. Okay. But the idea being that everything we're saying here, don't take notes on, because all of this stuff again is going to be available on the Canvas webpage. And so what we really want you to do is to be involved in the discussion, which we will have today. And as far as laptops and things like that, that's totally up to you guys as far as I'm concerned at this point. Sometimes with the freshmen, we like to not allow them to use electronic stuff, but if you want to use a laptop during class, and certainly during the 3-hour session on Friday, you're going to be working in teams. You'll be designing things, you'll be talking, you'll be taking notes, you'll be sharing them electronically, so it's fine. But again, I'm going to encourage you with this lab journal to do a lot of sketching. And if you want, you can digitize it and then find your own way to share those notes. But it's going to be critical that you do take hand notes at times when you're working in teams. And I think you guys should all have CAE accounts, except I'm not sure, probably our LNS students don't have CAE accounts, right? But they should be able to go over and run new user. Do you guys know where to go to run new user? It's 1410.
Oh, you can do that online too.
Oh, can they do it? Can they just do it right from here?
You can do it from the,
okay.
As long as you're enrolled in the engineering course, which this is, you should be able to set up an account.
All right, so go ahead and set up an account. I'm not sure exactly how they're going to utilize this right away, because they should, as long as you're registered, you should be able to get to the Canvas webpage, which is the bottom line.
I think it's more about accessing computer labs.
Okay.
Sort of.
Yeah, because at some point Gus is going to be talking to you about tools that we're going to utilize to try and draw things when we get to the design point in the class. Again, this is the web page that you need to have. I don't know if this has been sent to you or not, but I would definitely today sometime bookmark it, because this is where everything's going to be for this class. All right, and even these, what's being recorded, correct, is going to be on there.
And I think,
so if you want to go back and look at the lectures or discussions.
Yeah, I think it should show up in Learn at UW too.
Okay.
So as long as you pull up your Learn at UW, this course should pop up, and the Canvas site should be able to, you should be able to click to the Canvas site from there.
Okay, find it either way. That sounds good. So the other thing we're going to have to do in this class is we're going to want all of you to get a shop pass. Now it's going to cost you $50, so there's no textbook. The way you have to think about it is that's sort of your textbook, but we expect that pretty much most of the teams are going to build some sort of prototype at a point. And then we're going to go through, and anybody, so how many of you have shop passes? We can assess that a little bit. Raise your hands high if you have a shop pass. Is that red or green?
Green.
Green? Red?
You have to like redo it every year?
Well, you don't have to redo it, but you have to repay if you want to use the shop. So what, do you have a red pass from previous semesters? So it looks like there's a large group of you that don't have passes, which is fine. So Gus is going to talk about that later on, and he's going to take you through and he'll work with you on how to get the shop pass. It's going to cost $50, but it's worth 10 times that. So it's not a big deal. Because one of the things that's fun about this class, or we want it to be fun, is that we want you to come out of your comfort zone. And I know that your generation, you know, I'm the old guy here in the audience, but your generation is very IT astute. You're very strong with computers, but a lot of you haven't been able to use a table saw or haven't had the opportunity to look inside an automobile engine or to do fabricating or machining. Some of you have maybe. And I'm no expert at all. Gus is much, much stronger than I am. So he's going to be our fabrication consultant on this. But that's part of the fun of this class, is to go outside your comfort zone and do that. So within teams, and we'll talk about this as we're building teams, we don't want you to balkanize. We don't want things to balkanize too quickly. We want you to share roles and go ahead and go over and play with a bandsaw and do those kind of things. And it's going to make you a stronger engineer. It's going to make you a stronger policy person, environmental studies student, whatever it is. So this is just a page that describes how you're going to have to go about. This is you can begin doing the online quizzes, which are required. It's all very self-explanatory. What we want you to at least get is what's called a red shop permit, which is not very difficult to get. And at some point after you've completed all of your quizzes, it's going to ask you to give them a credit card where it's going to take a $50 fee. And then what happens is you then have to sign up for what's called a seminar, where you do a hands-on, and you go in for 2 hours in the shop and they take you through and you actually do some hands-on operations. I think, what is it? They do a bandsaw, drill press. They usually do some sanding.
Drop saw.
Drop saw. So you're not going to do any heavy machining. You're not going to learn welding. You're not going to use a CNC or anything like that. But if you enjoy it and you want to advance onto the Green Pass, or you want to take more advanced classes in woodworking, those are available free to do there once you get that first permit. And in fact, maybe what you're designing, the prototype, or if you're building something that you're going to show at the end of the semester, we'll talk about this in more detail. You may need to go and get those skills. So that's something your team is going to have to assess. But we would like all 19 of you to get a shop pass, all right? We'll talk in more detail about this as we move along. So if you look at the course structure, the syllabus is on the web page, and I think we do have sort of a pseudo syllabus, right?
Yeah.
At the top. But the best way to think of it is the Canvas, the week-to-week Canvas operations or modules. That is the syllabus for the class. And we don't have it all filled in yet, because we're going to bring in guest speakers. I don't know if we're going to talk today a little bit about the syllabus, but we're going to bring in guest speakers at different times. And the idea being that it's a very fluid situation too, depending upon the needs of the class. So we may decide that, oh, we need to bring in someone to talk about this. We may need to bring in a fabrication consultant, a design expert, I don't know. but it's going to be changing. But always, so I would regularly check the Canvas webpage for the class, and that's how to keep up with things. So remember that not all the lectures or discussions are directly relatable to design, but in this class, I would say most of them will be. And it's not just design, it's really bringing sustainability and sustainable energy into design. So that's an area where Scott's going to be very strong in sort of teaching us sustainability. Again, it's on the webpage. Thursday's a discussion. And if we think about Friday, what we're generally going to do on Friday is if we have some sort of lecture content or some sort of activity, we're going to do that up front for the first hour. We'll take a break. And then the last 2 hours are going to be working in teams as we move along during the semester. Now, in the beginning, there's going to be more, it'll be hands-on discussion-based stuff. There'll be some lectures. We're going to try and make them as dynamic as possible. But when we get halfway through the semester, basically that 3-hour period, most of it is going to be spent working in teams. And so we'll always meet here. The team, you'll have some sort of team meeting, and we'll talk about how we want you to function as teams. And then some of you may be going over to the College of Engineering shops in the basement of ECB. You may go over with Gus. You might have to work on your product. And you're going to have to do some work outside of class too. That's inevitable in a class like this, when you're doing a project-based sort of thing. We've already talked about the instructional staff. Now grading, and this is going to be Scott's purveyance. This is his area. The simple way I would describe it is about 75% of it is going to be a team component. And roughly about 25% of it will come from individual sort of assignments. And they're not going to be difficult assignments. It's going to be stuff, we might want progress reports or status reports. We might want you to give us a timetable or some sort of a Gantt chart or some sort of schedule as to how you think your project is progressing. And so we'll let you know about this sort of stuff as it comes up. But the bottom line is if the team does a great job, then everyone should do well in the class. What I normally tell students for senior design, and for some of you, you're thinking of this as capstone, and especially for the sustainability certificate, you don't worry so much about the grade. What you would like to do is you would like to produce a design or come up with an idea, put together, whether it's a paper design or a paper design with an artifact and some sort of prototype, something that you would show employers if you were trying to get a job, or you might even want to show people if you want to go to graduate school, if you're interviewing for graduate school, something that you would want to bind up. If you feel that way about your project at the end of the semester, you were very successful. That's how I would say it. So I know I'm not being very detail orientated here, but roughly think of it in this term. And we didn't want to break it down that this assignment is worth 1% of your grade or this one's worth 2%. But this is roughly the breakdown of how it's going to be graded, put together. Are there any questions on that? I know the world you guys live in, GPA driven, and it's not your fault. It's sort of crazy. I could care less about grades at my state in life, but it's just
Nobody's going to ask your GPA 5-10 years from now.
Yeah, that's the other thing we're joking about. I mean, once you get out of college, and in fact, nobody asked me in college, but once I got out of college, I mean, no one will ever ask you what your GPA was. They don't care. They're going to ask you, I mean, is this person fun to work with? And fun's a word that's going to come up a lot in this class, and you'll see why in a few minutes. We want it to be fun. And can you work with this person? Do they have a good technical background in whatever it is, or policy background from that end of the spectrum? It's all sorts of things that make you productive, right? So success in this class, and this is sort of parrots what I talk about with the freshmen sometimes, but do the little things that matter, that make your team strong. Again, building a good team, and none of you know each other yet, or you may know each other a little bit, but we're going to spend some time, whether it's today or tomorrow, we're going to spend some time where you can talk to each other, get an idea of maybe what sort of projects you want to work on, who has common interests, and then we're going to start building teams. But if you have a good team And if you put effort into that team and you meet outside of class, and not just to do analyses or drawings, but I think you got to go get pizza together. And you have to do those kind of things. And you have to get to know each other. And if you do all those things, it just makes the dynamics of the team that much stronger and better, all right? Communication, we're going to see a video where they talk, and we'll deconstruct the video at one point where they talk about active listening. And that's so important. I mean, everybody can talk like I'm doing now, and you guys are either active listening or you're really good at faking it, which I appreciate, all right? And I get that. We're all good at faking it. But I've got Bill Gates stories I'll tell you later in the semester. I've never met Bill Gates, but I've met someone who has worked with him on some nuclear reactors because he's a part of a company now called TerraPower, and he's a very quiet guy who actively listens. It's interesting in meetings. He's not up there dominating the meetings at all. He sits in back and he takes a ton of notes. So listening is very important. Work well in a team, have fun. The world you're going into is very creatively driven. It's not the world I went into when I was your age. And if you look at what people are paying for now, and I don't just mean that in a mercenary sense of the highest salary, but whether it's public sector, private sector, the people who are going to be running the show and making decisions, I mean, creativity is probably the number one thing. So you want to combine it with strong hard skills, whether it's economics, whether it's engineering, whether it's policy, and then you have to have strong soft skills where you can work with people, you'll listen to them, you're empathetic, you can take a leadership position or you can follow, you can take on these different roles. But then also you've just got to think outside the box. You got to do all sorts of things. And we're going to go through brainstorming sessions in here where we're going to encourage that sort of crazy thinking. Now, it's not crazy, but different thinking. And we're going to like wild ideas. And I say stay focused in lecture and lab. There's times when, especially when we have that 3-hour session on Friday, if you're working and you're just feeling tired and sleepy, and just get up and walk around. And where is the break room, by the way? Is there one down where they can go get a soft drink or something?
So there's a bathroom and the drinking fountain are on that side. And then if you go all the way around to kind of the glassy area, if you go all the way around the corner, there's a couple of vending machines that you can get soda or snacks.
So I don't know, can they drink stuff in here? Is that okay? Yeah. So my thing is if you need to get sugared up, do it. I mean, just go for it, whatever it takes.
And actually,
yeah, we don't, nothing more than that, but yeah, but we want to keep it. But I get it that I mean, you see a 3-hour Friday afternoon thing and you're just going, oh my God, this is going to be horrific. Well, it's not going to be. We're going to, and part of it is it's the same when you're a professional. If there's a long meeting, you got to get up and stretch, walk around, do it. Don't worry, don't hesitate.
And actually, so every Thursday in our building, we have tea time from 2 to 3. And so after this class, you're welcome to grab a coffee or tea and some cookies and
great
wiggle around. So that's an extra incentive to come to the Thursday class.
Okay, perfect. So that works out great. All right, so at the end, and this will be different for different teams, but there's no final exam. There are no exams in this class. There's no quizzes. We're going to have a few of these small assignments as we move along through the semester. We're going to have some design reviews where at certain points we're going to stop you. I think it's weeks 6 and 10, but we could look at the Canvas schedule to make sure of that. And everybody will look at everybody else's designs and we'll critique them and get some good ideas and we'll share ideas. But ultimately you're going to provide some sort of design report. You're going to have a presentation at the end and you'll be doing this in the design reviews. And it'll be a very relaxed setting. And then ultimately you might build some kind of functioning prototype. If you're doing a huge project or you're analyzing a wastewater treatment plant or something and coming up with a new way to optimize it from an energy standpoint, well, you're not going to build a prototype. Maybe you'll do some 3D modeling if we have budget for that. You might just use a 3D modeler to come up with some sort of something to show scaling on that. But the point being that you're going to produce something for a client. And your clients will be us essentially, unless we come up with some projects where we have outside clients. And we're going to talk to you a little bit about thinking about what you want to work on. We'll touch on that today. So Any questions at this point? Because I'm going to quickly zip through this because we're going to be talking about this tomorrow. This is the design process. Some of you who sat through 160 have seen these sorts of slides before, and so I won't belabor it too long, but ultimately, we take customer needs and we take these hard, what would be called hard skills, and you can put economics and all sorts of things in here with it. And we have this process where ultimately we produce a final product. So that's just a little cartoon. But what's really important here is to understand what the customer wants when you're designing anything. And this is not just an engineering artifact. I would make the argument, engineers didn't invent this. This is a process. I like to say that if someday when I have my bypass surgery done, that I hope the doctors and the nurses just don't show up and wing it. You know, I hope they have a plan and they've talked a little bit about it and they've brainstormed and they know what are potential pitfalls and solutions and they've thought about it. And they have a process they go through. The same with a legal team, teachers, all sorts of professionals do this thing, do these sorts of things. So I think of this as a very generic problem-solving algorithm. Is the way I would look at it. All right. But ultimately, we need to produce something that's useful for the client. So there's lots of little twists on the design process. You're going to hear it. You'll hear us talking about different ways of doing things. We may take different viewpoints on it, and that's fine. And in fact, you may listen to me and go, yeah, that's okay, but I want to do it this way. That's great, because everyone should put their own twist on it. And that's part of the fun of it. But ultimately, I can jump right to the bottom here and we'll talk a little bit about some of this stuff, but there's a roadmap for design that we want you to follow. And when I say design, I mean, my wife works in the Women, Infant, Children program. And every once in a while, they have these retreats where they go away for a couple days. And they talk about how they want to improve the program. And she follows something very similar to this when they're going through and they're redesigning their program. So it's not so don't think of this just as engineering design or anything. It's really, again, an algorithm to solve problems. You want things to be functional and useful. You want them to be safe. So let me ask you this, because I don't want you guys to get too sleepy. What does safe mean? And don't worry, there's no right or wrong answers. So what does the general public think when they think of safety?
Nobody's going to be harmed.
Okay, so nobody's going to be harmed.
Nobody's going to get sued.
Nobody's going to get sued. So the company thinks about that. There are liability issues.
Anybody can use it.
Anybody? Yeah, anybody can use it. Now that's going to depend upon the type of product that you're developing, but right. But I guess what I'm getting is, what does the term safe mean? It's incredibly vague, right? And the problem is, so what's 100% safe? The answer is nothing. I'm sorry to say, this is a nuclear engineer talking, all right? So nothing is 100% safe. So anyone who tells you that is immediately wrong or probably lying to you, all right? But I understand that you can't go through statistics with the general public when you're trying to describe how things function. But you've got to figure out what's an acceptable level of safety when you're designing a real product. This is not a theoretical situation anymore. So engineering or design, what we're doing is really applied physics, and it's very human-centric. And you're going to have to somehow explain to the customer. Some of you guys who took 160, do you guys remember the talk on clean water by Greg Harrington? Anybody remember that? What's the value of a human life? Which is kind of a tough lecture. That's not what the whole lecture is about, but he sort of shows students that in reality, and the point here being, when you look at safety, we have infinite aspirations. We have infinite sort of desires for safety, but we have finite what? Resources. So we don't have infinite resources. So how do we take these finite resources and how do we distribute them so we get the optimal amount of safety? But you can't get 100% safety. And that's something that with the public, we're much more soft in discussing this, but in this room, we can't be soft, because if you're actually designing and building things, there's gonna be some sort of way that it can be misused and mishandled, and tragically, people can be harmed utilizing it. We'll talk in more detail as we get into design on that. Don't, always stay in touch with the client, because you don't wanna chase the wrong problem. Sustainability and design, Scott's got a good link here.
Yeah, and this is something that I shared with you all. Hopefully, you're able to look through it. One way of thinking about the projects that you're going to work on is, pretending that you're part of this engineering design curriculum, engineering design competition, which is called P3. I'm sorry, environmental design, people, prosperity, planet, and if I can make it bigger. There we go. That's not showing up too well. Anyway, I think most of you have received this, and it's also on the Canvas website, so I encourage you to look through it. It just gives a nice snapshot of when you're looking at your design, think about the environmental impacts, the social impacts, the economic impacts, and within each of those categories, there's these other kind of sub-points. And so we want you to really incorporate, you're not going to touch on every single thing that's listed, but as you're putting your project together, what aspects of sustainability are you really going to touch on? Are you going to focus on environmental justice issues, educational about issues, educating people about sustainability? Are you improving air quality or reducing greenhouse gas emissions? Are you improving water quality? Is this something that will save people money? Will it create new jobs? Will it, increase prosperity for certain populations? So that's sort of, as you look through, as you think about your design, think about the whole life cycle impacts too of your product, and in not just an environmental sense, but the social and the economic sense of things.
Okay, so that's very useful to look at, and as he showed the circles where they all intersect, that's where we want to live from a sustainability standpoint.
I would add that, that middle point, it's not necessarily that there's a perfect sustainable solution, but that's sort of the goal, that we're trying to be more sustainable in how we do things. And so you're going to have to make trade-offs. Something might be really good for the environment, but cost a lot, or might have certain impacts on certain populations. And so you're going to have to balance those different issues and kind of develop some metrics as to, okay, what are the impacts both on environmental and the social and the economic, and which ones are really good, which ones are sort of good in each of those metrics, and really develop your own sustainability metric.
Okay, that sounds great. So I'm not going to belabor this too much, but cost, quality, and time, we're all constrained. We're going to do a tower building exercise. When are we doing that?
That's next week.
Next week sometime. So some of you have done this probably already. It's a little hokey, but it's fun. And I think it also gives you an idea of when you get to the end of the semester, it's going to feel like you built a tower, even though you had 15 weeks, lots of time, more budget, things like that, because we're just constrained. And you're going to learn about those constraints. Everybody wants it cheaper, faster, better. You've got to communicate this with the customer. And again, what we're really talking about is this roadmap. How do we follow this roadmap, this process to take us through design? Very quickly, we're going to talk about this tomorrow more, but this shows you establish the need, you talk to the client, you have to then, as a team, understand the problem. You generate a solution via brainstorming, and that's really the super creative portion of this process. You then have to have a methodology for evaluating all these ideas and coming up with what are the highest worth ones that you can try to incorporate. And then you develop a detailed design, you document, you test, you build a prototype, you test the prototype, and what's going to happen? What's going to happen? I heard it. It's what?
It's going to fail.
It's going to fail. Okay. So why is it going to fail? So Grandpa told you what? And I know I've used this line in front of some of you too many times. When you were painting the fence, Grandpa said, do it right the first time. But building a sustainable design, whether it's a wastewater treatment plant or an integrated solar plant, it's impossible to do it right the first time. It's too complicated. The sorts of systems you're looking at. So what I'm getting at is if you really want to be creative in how you design things, failure is good. Fail early, fail often, and that's great. Now, I always tell students that 10 seconds after the rocket launches, that's when we would like to avoid failure in aerospace. But the point being that while you're going through this and you're engineering something, we learn a lot from failure. In fact, we test a failure on a lot of systems, so don't worry about that. And we're going to see that in here. You're going to come up with an idea, you're going to go over with Gus, you're going to try and machine something, and you're going to realize, wow, this isn't workable. We can't machine it this way. Well, that's okay. You're going to have to come back, maybe come up with a new material, maybe come up with a different way to fasten it. You're going to fail, but that's good, all right? And then what these lines show you is that this is a very iterative process. We just spin through this process all semester long. We get to the end. We don't have a perfect product. Nothing's 100% safe, but we feel we have something because of the time constraint that we want to release. And if it's sufficiently, and depending upon the time constraint in industry or the public sector, we have something that we feel we can release to the public and utilize, we then release it. The example I always use is, how many of you, what iPhone are we on now? It's still not i1, right? Or I don't know if there ever was an iPhone 1, but the idea being we're on, what, 7? And when's 8 coming out? Probably pretty soon, right? Or, I mean, it's just every 6 months or whatever.
Actually, 8's already finished, not released yet, and they're already working on 9.
Okay, yeah. So it just shows you that they're adding more and more capabilities, but it's never, I mean, perfection, nobody reaches perfection. And I don't need to explain that to you. But the idea being that, so design is just very iterative. And when you see the IDEO video that some of you have probably already seen, and we're going to see that at some point, he talks about you just have to stop at a point because it can go on forever and ever. And that's what he's really talking about, is that as we move through here, there's always things you're going to find, and there's always things that you need to improve. All right? Past projects, I'm not going to talk too much about this, but there's all sorts of things that we've worked on in different classes. And again, we've used the same sort of methodology on all of these projects, whether we were working with a zoo, or we were working with disabled adults, or building a playground that was handicap accessible for children in Honduras. We've done all sorts of things along these lines. Then again, here we'll be talking about, we're going to have all these extra lectures. We'll have guest lectures on sustainability, obviously energy, analysis, fabrication, globalization. This is one that, and I was glad to hear, who went to China? You went to China. My daughter did that a few years back. That was a Hangzhou?
Yeah.
Yeah, it's very cool. How many other students have studied abroad? Okay, hands way up, just because I don't. Okay, how many of the rest of you would like to? Hopefully you're thinking about it. It's amazing to me, and I'll tell you stories as the semester goes on. I won't now, but we have a John Deere plant in a small town in Wisconsin with about $400 million invested in it. And it amazed me 10 years ago how globalized their supply chain was. It was just incredible. So whether you're a policy person, you're more chemistry driven, you're more design engineering driven, whatever it is, you live in a globalized world, and it's not going backwards. I don't care what the politics are of the day or what's going on. You can't put this genie back in the bottle, so to speak. And that's good. I think a globalized world is, in my view, is a better world. And we can work together to solve problems. So if you can get the experience of studying abroad, that's fantastic, is what I'm getting at. We'll talk a little bit about these things. We'll do a lot of case studies. And this just gives you a rough idea of what we're going to see in the class. So real quick here, towards the end of we've got about 6 more minutes. I've shown this, probably some of you have seen this, and it's getting less and less relevant because you guys are a little older, but I just talked to a freshman class. They were all born in 1998 they were born, which is pretty amazing to me. But if you think back to the 20th century, so the 1900s, and just shout out some ideas, what were the most important inventions of the 20th century? I mean, what do you think? What?
Airplanes.
Airplanes, air travel,
Automobile.
automobiles, because, so you gotta go all the way back to 1900, and none of these things were invented in 1900. What else? Internet, so nuclear power, computers, right? Think even in a more, I mean, even farther back, how did we power the world in 1900? So it was steam powered. Did we have electricity? The National Academy went and listed from 1 to 20 in order what they thought were the most important inventions. Number one, and this is clear to me, the only other one that I would say is as important as this is right here. And if you get Greg Harrington, who gives a great clean water talk, you realize that so much of your lifespan, so much of your life expectancy that's been increased since 1900, and I'm not poo-pooing the medical field, all right? God bless our doctors and nurses and all those people. But your life expectancy was about 50 in 1900, and now it's about 80. About 25 of those years comes from clean water, not from medicine, believe it or not. And most of that comes from infant mortality. The fact that we've gotten rid of infant mortality with clean water. So you think a civil engineer when you see one, all right? I'm not one, so. But clean water is huge, and this is a problem all around the world that we see that, to me, this is a goal that I'm probably not gonna see in my lifetime, but hopefully in your lifetime, everybody on the planet has clean water. That would just be an amazing, that would just raise the level of, make everyone's lives so much better. But you see the sorts of things that were invented in the 20th century and were so critical. So let's jump to your century. So as I always make my bad joke about, I'm gonna be on a beach drinking a Corona when the global warming wave comes in and just wipes me out, right? So, so this matters, but my generation, I'm a baby boomer, and we're kind of sticking it to you guys because we're dumping a bunch of problems and also a lot of debt on you guys. Don't beat me up after class, all right? But this is your century. So right now, how many people live on this planet? And this is kind of how an old man thinks. So, right, 7 billion. So I like to talk in numbers like that so we get scaling and we get an idea of what's happening. By 2050, how many people are going to be on the planet? Anybody guess? What?
Is it 11 or something?
Yeah, I'll tell you what, I thought it was 10. Somebody told me yesterday 12, and you're saying 11. So it's going to be 10, 11, 12 billion people, somewhere in that range. And then it's supposed to top out at about 2050, which is good. You know, we're not Malthusian. We're not going to go totally crazy, but there's going to be 10 billion people at least living here 20 plus years from now. Or actually 30 plus years from now, sorry. So what kind of problem, I mean, you guys should be concerned about this. What are the issues that concern you? And these are what are called the grand challenges. The term was utilized. And this is stuff that you're going to need to worry about. So the other thing I would tell all of you, regardless of what you're studying, I tell all of our engineers that you're going to be a mechanical engineer, but you're all going to be environmental engineers. Because your company cares about it, your community cares about it, we just don't throw stuff away anymore. Factories now, I remember when I was a kid working in factories in Fond du Lac, and they were dirty, and we'd sweep up and clean. I mean, factories now, Gus, right, you can almost eat off the floor. It's amazing. And part of that is to save money, but they just don't want to produce waste streams, that they then have to deal with those waste streams. So what are the issues that concern you guys? Okay, global warming, climate change, okay, food production, clean energy, what?
Space.
Yeah, just generically, will we have enough space for people? I think we're pretty good here, but some countries are going to be very crowded, right?
Water.
Water.
Waste management.
Waste management, so throughputs, right. Waste streams. This is what they came up with, a list of 14 things. And they got a little more specific. What's interesting to me when you look at this is that out of these 14, you can take roughly 10 of these, and they generally fall into the area of healthcare, energy, or sustainability, or they rub up against those. And so there's a bit of a triangle in our engineering college where I would say at least half, if not 60 or 70% of our faculty are studying things that involve those areas. And that's where I talk about this triangle right here, all right? And these issues, they transcend all disciplines. And especially Scott's going to mention this in later lectures, that energy and sustainability are very coupled, all right? Healthcare is sort of the 600-pound gorilla in the room because it eats up about 18% of our economy, of our GDP, all right? Which you maybe go, what's 17%? Well, that's 4 times bigger than defense spending. Defense spending is about 4% of our GDP. I'm not talking about our public, I'm saying the entire economy. So healthcare is just huge. So any sort of, based on economies of scale, any sort of improvements we can come up with can have a huge effect. And then this is my one apology, I won't belabor this, but this is what my generation is kind of doing to your generation. So you guys need to be concerned about this, that we're leaving you with a lot of problems and not much money to do much with the problems, because we're going to also leave you with a big bill, after the party's done. But so I don't want you clinically depressed, right? But look at these as opportunities, because there's going to be huge opportunities for people who are interested in what you're interested right here in this class. That's the way to look at it. I got just a couple things here. These are diagrams. Scott's going to probably talk on them more when we get time because we're running out. But these are really neat diagrams that we can find. What's this called? The Sankey?
The Sankey diagram. Yeah, this just shows the energy flows in the U.S. Over here are all the sources. The primary sources. We got petroleum, coal, natural gas, renewable energy, and then you see all the different end uses. A lot of it goes into electrical generation. Some of that then goes into residential, commercial, industrial. Some goes into process heat. The couple of main points is that just about everything has an energy impact, no matter whether it's the products that you buy, how much water you use. Everything eventually has an energy impact. So that's why I talk about energy and sustainability are interlinked. You can also see there's a huge amount. This is rejected energy that's just not used in any useful way due to basic thermodynamics of power plants and internal combustion engines. And especially, for this class, you're probably not going to solve, these are big picture, multi-decadal issues of how are we going to transition to these sources. But I think for an impact, more immediate impact, think about all the end uses that we have and ways that we can make this more sustainable so that we don't have to rely as much on these sources over here. Right. And actually, I'll post a link to this. This basically takes this diagram and then it's an interactive link where you can see how much of all the industrial energy goes to chemicals or petroleum refining or paper. And it's a kind of just fun little website just to click through to see, wow, really, all of our energy is going into these things.
Right. So that's a big part of this class is Scott and I and Gus are going to try and provide you with some resources. Just so if you get interested, you can, because that's at Lawrence Livermore National Lab. These things are up there, you can go find them and you can just get together and have discussions. Again, a big thing about this class is doing that kind of stuff. Having these bowl sessions, go to the union, get pizza, have fun, talk about sustainability, energy. That's what it's all about. Okay.
Yeah, and if you need a particular expert on campus, to maybe have a quick interview to help you with your project, I'm here to help you, point you to the right person as well.
Right. Okay, I think that's, we're a few minutes late. Sorry about that. We'll try to get you out on time and we'll see you guys tomorrow at 1, right? Yep.